Imagine having an AI employee that exactly knows how your company speaks, knows your product differentiators inside out, and can draft you perfect cold outreach emails while you sleep. And no, I'm not talking about generic ChatGPT wrappers. I'm talking about a model you own, running on your own data and in a really secured environment. The clip you just saw was not running a supermassive model on a supercomputer. That was just a small language model, specifically Google's 𝗬 2 billion parameter model, that I fine-tuned to draft personalized emails as per the company's requirement. But getting a perfectly fine-tuned model wasn't a straight line for me. I have to try several models like Google's 𝗬 270 million, 𝗬 1 billion, and those models hallucinated. Sometimes I was getting the error of context window limit reached and many more issues which I faced while fine-tuning this model. So in this video, I'm going to walk you through the exact Python code I used in every single cell and show you how I fixed the bugs I faced, so you don't have to face all those bugs and you could train the model yourself for your requirements. Okay, so before we start with the explanation of the code part, I would like to tell that I have been using Google Colab and I have fine-tuned the whole model on Google Colab using the T4 GPU it provides. The one limitation which I saw while training the model was it disconnects the runtime, disconnects and delete the GPU runtime after 5 hours. So the T4 GPU is only allocated for 5 hours per day, and there is certain time period after which you can again use the T4 GPU. But what I have noticed is it takes around 24 hours to reset the GPU runtime. So it would be better for you to save all the training weights and the tokens to the Google Drive folder after the training is done or while the training is being done, so you don't get your progress lost. Now let's start with the explanation. So what I'm doing here is I'm importing all the necessary libraries like JSON, regex, logging, random. As you know that JSON is used for reading and writing the JSON files. Regex is used for cleaning the dataset, which we will be doing further. And pandas is used for processing the CSVs. Copies used for deep copying the stuff, which I will show you further. So I have already set the logging for the errors logging, bugs logging, information logging. So we don't need to use print everywhere. We can get proper logging done using this library. Further, I'm installing all the dependencies which are required. So transformers is used for loading the model and the tokens and the tokenizers, and accelerate is used for accelerating the GPU and optimizing the process. PEFT stands for parameter efficient fine tuning. It is basically it's a technique in fine tuning where we don't need to entirely fine tune the whole model. We are actually fine tuning just a part of a few percent of the parameters of that particular model. So in my use case, I'm using 2 billion parameter model where I won't be training the whole 2 billion parameters. I will just pick a chunk from that 2 billion parameter model and train that part to become my specialized agent. Now, yeah, talking further, we have Hugging Face Hub, as we have imported the PEFT library from the Hugging Face itself, and TRL for the training initialization part. I was also using Streamlit to actually host the whole model on the platform where any user who is non-technical can use that platform to generate the emails. And then we can use nvidia-smi. Currently, I'm not running the T4 GPU, so it's showing error. But we can see configurations of a GPU, what is the temperature, what is the name, what is the CUDA version, what is the GPU we are using. Now, the essential part comes here. We are cleaning the dataset first of all, because our dataset contains many features which would be null, none, nan, and other kind of terms which might be representing that this feature is a null value. So in my data set, I had around 151 data records, which is rows, and 52 columns, which is features. So many of the features of a particular record were empty, and some of them might had white spaces, some of them had non-null values. So we are replacing everything with this string with just empty blank spaces. And then in the next function, the truncate function, this is really important function according to my use case, because I am using a 2 billion parameter model and it has only the context window of size 2048 tokens. So I cannot exceed this token limit. If I exceed this token limit, then the model will give me OOM error, out of memory error, and further many more errors. So what I need to do is I need to optimize my input data and output data as much as possible, so that my model gets trained perfectly on the data, and then whenever any user uses it for the inference, then it processes smoothly. So what we do here is we are first checking that if any value is none, then we are returning the empty string. If the length of text is less than max length, as you can see, we have already set a max length here, which is 400 characters. If the length of text is less, then you can return the whole sentence. If okay, so the real magic happens here. You can see we have a for loop. We are creating a list here, and how we are creating a list, we are checking if the sentence has ended. So how we are checking by these expressions, by these punctuations, full stop, exclamation mark, and question mark. These punctuations are being used to check if a sentence has ended, and then if the sentence has ended, like for example, my name is Danish, full stop, and I am an AI/ML engineer. So this sentence will be created as a list. My name is Danish. Danish is one element inside a list, and I am an AI engineer is another element inside the list. Assume that I have set the maximum length of 10 characters, and my name is Danish and I am an AI. Till here, the character maximum length is completed. Now, what happens is the system is trained on this data. My name is Danish and I am an AI. It's really a disaster, because it's the meaning of this sentence says that I am an AI, and we don't want that. I am an AI/ML engineer. So the meaning of the sentence completely gets destroyed, and we don't want this. So we are using the for loop and appending every sentence one by one until the max length is reached. If the max length is reached after entering one more sentence after the punctuation, then we won't add that sentence and we will return the string. Okay, so this was just a raw example. Now talking about the structured input data. Okay, this cell basically structures our whole input features. So whatever input features we have, like prospect name, title, company, industry, LinkedIn summary, and all the other features are grouped into a particular type. So what I mean to say is our model is really very beginner in understanding any of this thing. We have to explain it from the starting. Like we study from A, B, C, D, and then we try to make the sentences words, and we try to make the sentences through those words. We have to teach the model like this because it's really a beginner and it doesn't know anything. So what I'm doing here is I have grouped all these input features into three categories: prospect, company, and task. So the model can understand that prospect means there is a human being who has a name, who has a title, who has a company, who is working on some industry, who has a LinkedIn profile, and who has a summary. And when we talk about company, then it's talking about recent activity of the company. I hope you're getting my point. We are talking about recent activity of the company, not of the prospect. So this is why I had to group these data for better model context understanding. And then we have some pain points: use case, channel, obviously email, and constraint of less than 150 words of email. Then we are processing Google Sheets and creating the JSONL file. I don't know if you have heard the term of JSONL. JSONL just means that JSON lines. Now what happens in JSON is a really large block of code with key value pairs, and we don't want that really large block, because assume if you have a 10 GB data set, then it's a really big data set and you cannot load that JSON file. Your VS Code will crash and you cannot load that particular file, which is optimized by using JSONL file. So what JSONL does is it has a input data and has output data in just one line. So input will contain all the prospect details, company details, task, and output will contain all the emails in just one line. We don't need multiple lines, multiple block of code to represent in JSONL. It just has the one line. Just to tell you that all the major fine-tuning standards uses JSONL files for the fine-tuning and model training process. Next, we have created a function extract all emails from the row, and in this we are extracting all the emails. So in my use case, I had 4 types of email for a prospect. So there is a prospect named Danish, and it has been sent 4 types of emails. First is posh, second is CSR, then the follow-up of posh, then the follow-up of CSR. So I had to create duplicate of my name, the whole input with all the email types and the output email of a particular type. So this is what I had to do for more better understanding of the model, because model is really a baby. We have to explain it from scratch that how this data is working and how we want you to train on this data. So what I'm doing here is we are training model. If we are sending a if I tell the model that generate an email for me, then it will generate an email, but it will ask me the type, and I have to mention the type if it don't ask me. After mentioning the type, let's say I want to generate posh email 1, then it will generate see all the data which it has been trained on, the posh email data, and it will learn that pattern, and then using that pattern it will generate me a new unique email following that pattern specifically. This is what is the purpose of fine tuning we are doing. So yeah, we are just extracting all the columns, and then we are processing the Google Sheet CSV file, and we are mapping the columns with the prospect name. These are the headers present in the CSV file, and we are just mapping those headers with the ones we want to use in the JSONL file for better readability and model context understanding. And then yeah, we are extracting all the 4 email outputs, and then we are executing it. So as you can see, we have generated 604 records after processing it. Now we see that we have another cell, field prioritization. Okay, so the main aim of this cell is to optimize the token usage. As you can see, we are using the truncate function. We are also like checking if there are any fields empty or not. See, you can see we are filtering the empty fields. We don't want the model to learn those empty fields, so we will remove all those empty fields and make the model more optimized, and we would like work towards the less usage of tokens in our model fine tuning. And next you can see that we have the prompt engineering part. This is a really crucial and critical part in fine tuning, because the more good prompt you give to the model, the more better it will understand the input and the output and learn through that pattern. So we have built some sections here. As you can see, we have prospect section, company section, and task section, which is being given a prompt like if follow an email, then the model will be getting this prompt, and if there is nothing else, then it will be getting the initial outreach email. And we have also we are also fetching the email type from the fields. So yeah, and then there is a prompt template where there is a role, instruction, and format. You are an expert email copywriting specialist trained to write different categories of post CSR emails. So the whole idea is to make the model learn the pattern, the tone, the way the company talks, so it can generate the similar kind of emails. It's just like ordering the same dish again and again from the model, but that same dish will be a bit creative, will be a bit personalized according to different prospects and different people. Yep, and then we are returning everything. So this is how we are creating a prompt template, and then the actual main part comes here. This is the end of the pipeline of pre-processing we were doing with the data, and after this flattened dataset function, we will have a JSONL which will be ready to be trained on a model. Now you can see here we have a skip if the core fields are missing. So it's like if prospect name or company name is missing, then we will skip that whole data record, and it's using the prompt create prompt function which we created just above, which is used for embedding the prompt in the whole JSONL. Okay, and then we are writing the whole new JSONL. Like before we wrote emails from sheet JSONL, now we are reading each and every lines from this old JSONL and rewriting it to train improved JSONL, so it contains the prompt as well. So now the input will contain the prompt, and the output will contain the output which it should give. And yeah, so as you can see, it says the output says here dataset ready for fine tuning with 600 examples. Okay, so let's see the data which is being generated now. The new JSONL file which contains the role. It's a bit messy, let me see. Yeah, now this is very readable, and it has a role like we specified, and it has a context. This is an initial outreach email of type posh email 1. As you saw here, we were mentioning the email type, and it's dynamically getting those email type from the fields. Okay, and then we have a task here, like generate the correct type of sales emails as specified by the email type, and there is a prospect section which we built. And let's check out where is the email type. Yeah, email type is working perfectly, and the truncation is also working perfectly. And you can see we have output as subject, body, and then everything is perfect. So this is a perfect JSONL which we will be giving to the model. Now let's get back to the code, and this was all about the processing of the data we have done, and we have created a perfect JSONL which can be trained on a model. Now we will be doing all the setup which is required for the training purpose.